Hello friends, here in this video we will see a new chapter, columns and struts, and here I am going to explain the concept regarding columns and struts. Let us get started. Columns and struts. Now basically when we talk about column is a vertical member which is used in case of structures for supporting the horizontal load over it, or we can say the horizontal structures. Like for example, column may act, or we can say it is like a pillar which supports the horizontal member, for example beam. So here I'll explain it in the form of a diagram. Now here I have drawn a diagram of a column. It is a vertical member and the load will be acting on this column. I'll say that this load is denoted as P. Here I'll write the definition. So here I have written the definition of column, that it is a vertical member of a structure subjected to vertical compressive load. Here if we see, the load is acting in the downward direction, column is fixed to the ground at the bottom, so there is compressive load acting on the column. And if suppose here I am assuming that the load is passing through the axis of the column, and that will result in the compression of this column. And if I want to differentiate between columns and struts, strut is basically it is a comparatively shorter column and it may be horizontal, vertical or inclined. So here is the difference between columns and struts. Column is a vertical member subjected to compressive load. In case of strut, it is smaller in length as compared to the column, and then strut can be horizontal, vertical or inclined. Struts are basically used in case of trusses or frames. It means there won't be direct vertical load on the struts. The load may be inclined or even horizontal. But in case of columns, the load is purely vertical. I'll mention here that columns are subjected to only vertical compressive loads, whereas struts are subjected to horizontal or maybe sometimes vertical or inclined loads. Next, Columns, as I have told, it is a structural member used in case of buildings and to support a structure. Struts are used in trusses, frames, etc. And as I have explained, column means a vertical member having comparatively longer length compared to the strut. Now after this, I can say that there are two types of columns basically. Types of columns. First is long column. Second, short column. Now I'll write down the definition for long column. Long column, it is that column in which the effective length to least lateral dimension ratio is greater than 12. So here I have written the definition for the long column. It is that column in which the effective length to least lateral dimension ratio, that is the ratio of effective length to the least lateral dimension, should be greater than 12. Then only we will say that it is a long column. Now I'll explain this. I'll also write the definition of short column and explain that with the help of diagram what is the meaning of long and short column. So for short column, it is that column in which the ratio of effective length to the least lateral dimension is less than 12. Now what is the meaning of lateral dimension and these definitions? That I'll explain with the help of a diagram. Now here I'll explain this long and short column with the help of a diagram. The column which I have drawn here, this indicates the length of the column. Now this is the length of the column, and if suppose this complete length of the column is bending, because what can happen is, because of the load acting on the column, this column may bend. In this fashion, suppose it is bending in this direction. So if a column is bending in this manner, then here the entire length of the column is bending. So the length of the column which is actually bending, that is called as effective length of column. Now from this direction I can see only the length of the column. If I want to see the other dimensions, then I have to look the column from top, and that will decide what shape of the column is there. So if I can look from top, and here I'll draw the diagram of two shapes, that is two cross section for the column. First, I am assuming that the cross section is circular. The diameter of this column, which is circular, I am assuming it to be capital D. Next, I'll assume the cross section as a rectangle. Now, here I have assumed two cross sections for the column. One is the circular section, other is the rectangular section. Columns may have any kind of section. It can be hollow circular, it can be hollow rectangle, I section, T section, any sections. Here I am assuming two sections. Now, for the long column definition, I have written that it is that column in which the effective length means I have shown the length of the column which is bending. So this actual length is effective length which takes part in bending. So that effective length to least lateral dimension. If I consider the circular column, the lateral dimension is the diameter. So the ratio of effective length to the diameter, if it is greater than effective length to the lateral dimension, if it is greater than 12, then we will say that it is a long column. Similarly, for the short column, the ratio will be effective length upon diameter of the column will be less than 12. Next, in a similar manner, here if I have a rectangle section, now I have to select the least lateral dimension. So by looking from B and D, that is width and depth, I can say that width B is less than the depth D. So width will become the least lateral dimension for me, least lateral dimension. So here, if I want to know that if this rectangular column is long or short, I'll calculate the ratio of effective length by B. So if I'll say that for the rectangular column, first case, if effective length upon B, that is the least lateral dimension, if this ratio comes out to be greater than 12, then it is a long column. And if effective length upon the least lateral dimension, that is B, the ratio is less than 12, then it is a short column. So here I have explained the meaning of long and short column with the help of example. Column can have any kind of cross section. It is not as such that there should only be round column or circular column or rectangle. Section can be anything. But here, while explaining for long and short, I have taken these two examples to explain the least lateral dimension. For the circle, least lateral dimension will be the diameter. For the rectangle, we have to take the minimum value of width and depth, that will be the least lateral dimension. So this was regarding the long and short column. Then if the column is long, I'll mention here, if the column is long, then it will fail only because of buckling, which is the other word for bending. So if there are long columns, they will fail only because of buckling, that is bending, and that bending will be in such a form. This is the buckling of the column. Then if the column is short, then it will fail only because of direct compression. So it is understood that long columns will fail only because of bending, whereas short column will fail only because of compression. That is, the compressive load will try to decrease the length of the column and increase its diameter, that is the compressive failure, whereas in case of long columns there is bending failure. Then after that I'll write down the theory which is used in the further part of the chapter. So for long columns, Euler's theory is used, whereas for short columns, Rankine's theory is used. That is, if we will be solving the problem, then for long columns we are going to use the Euler's theory, because Euler's gave us the formula regarding long columns and he considered only the bending of column, whereas Rankine, it considered even the compression effect, that is even for short column. So this theory, which is Rankine's, is used for short as well as medium and long column. So this theory is applicable to all types of column, whereas Euler's theory, it is applicable only for long columns. So in this video we have seen the concept regarding columns and struts.